is there any advice at all you have about building contracts or APIs that are really, really good experiences for other developers to build on?
Simplify, simplify, simplify. I think the midwit trap of code development is to stack as many specialized features and as much difficult code and as many fancy interfaces into a project as you can, just to show that you're capable, because it is impressive that you know how to do these things compared to a novice coder. The real advanced trick is, how do you make something not so complicated that you can't find a bug in it, but so simple that it's understandable by everyone. If you're trying to build a key building block of the space, other people's attention is the scarcest resource. And so things have to be both dead simple to understand and dead simple to implement without ways to screw it up. One argument that I've heard, for example, is if you have a simple API and then somebody comes in and says, hey, there's this weird edge case that 1% of users might use, we should stick it in there. And initially it seemed like there's no harm, because A, you haven't broken any existing functionality, and B, if this turns out to not be what people need, then they can just choose to not use it. So what's the harm in adding this complex edge case? But it turns out the harm is in the attention. People come to your website or come to your documentation, and instead of there being one clear way to do things, now there are 7 ways. And they have to go consult outside resources to figure out what the trade-offs are of each.
Hello and welcome to another episode of Devs Do Something. Today's guest is Foobar, a dev, writer, and auditor who is also a DeFi and NFT founder. You may know Foobar from Twitter, where he is a grade A meme poster and prolific commentator on all things crypto. He's also the founder of Delegate.cash, an immutable primitive to safely claim airdrops for vaulted NFTs. In this episode, we deep dive several of Foobar's projects, including Delegate.cash and a repo he calls Bored and Dangerous. We also asked Foobar how he personally levels up as an engineer and how he approaches things like smart contract security, trade-offs between immutability and mutability, and drafting EIPs. If you're a crypto native who wants to learn how a thriving Anon dev approaches their craft, then this episode is for you. I hope you enjoy. Are you a DAO or crypto native business with salaried employees? Or do you perhaps work for one? If so, whether you're a team of 5 or 500, your organization can save time and money by streaming salaries with Superfluid, who also happens to be the beloved producer of this podcast. With salary streaming, your management team no longer has to worry about executing multi-sig operations every month or manually executing hundreds of separate transactions to pay their team. Contributors and employees, on the other hand, get paid by the second, which, to be honest with you, is a pretty killer benefit on the receiving end. Those of us getting paid via stream can connect our wallet to the Superfluid dashboard and see our balances ticking up in real time. It's kind of mesmerizing and feels like you're being jacked 10 years in the future. When you're paid in a stream, it flows in perpetuity until your team needs to adjust compensation, which effectively puts Web3 payroll on autopilot. Salary streaming is easy to set up thanks to our recent integration with CoinShift, the leading crypto treasury management platform. In just a few clicks, you can securely set up payroll for hundreds of employees in just a single transaction, all from CoinShift's dashboard. If this sounds like something you're interested in exploring, you should visit superfluid.finance/payroll and book a salary streaming demo today. Thanks to all of our sponsors. Let's get on to the episode. All right, so we are here today with Foobar. Welcome.
Thanks. Great to be here.
Yes, we're pumped that you came on and joined us today. The first question we tend to ask everyone who comes on is a bit of a general one, but it's always good. How did you get involved in crypto?
Great question. It's been a bit of a winding path, I would say. Started out in general computer science and then went hard into the artificial intelligence, machine learning world for several years. Actually, briefly set some world records on that front. But within the ML space, kept getting pulled more and more towards open source work, both using existing open source repos, pushing stuff back, and generally that open philosophy. Got pulled into crypto when I realized it was the supercharging of the open source movement. You get open source, open state, everything shared in real time. So started tinkering, did a bunch of fun stuff, got pulled in more and more and more. And before you know it, pulling 80 hours a week across the DeFi, NFT, and more space. So here we are.
I love it. I love it. Yeah, it looks like you come from also, I think a little bit of a math background as well. I feel like I either read somewhere or heard you say somewhere in a separate podcast that you got very into like both the CS and mathematical side of ML where you were involved there. And correct me if I'm wrong on that, by the way.
Yeah, actually went pretty deep into the math side of things. A lot of programming was to enable that. I think that's what really piqued my interest on the ML side of things is it's not just coding. You need some pretty well-founded mathematical intuition and whatnot. And then same thing with crypto. Obviously, there's a ton of programming involved, but you have to know what a hash function is. You have to know what consensus mechanisms are. There's a lot of security and stability parameters that come along in a lot of these DeFi protocols. So I'd say math is just the common underpinning. Still have a ton of curiosity there.
Nice. Are there any pieces of math that you found in crypto so far that are particularly beautiful to you, or anything you think is like particularly cool, whether it's on like maybe the more economic side in dealing with like protocols or like DeFi protocols, or some like the hardcore cryptography and ZK stuff? Is there anything you found that you really like?
Yeah, several things. First of all, the ZK cryptography is probably the most unintuitively beautiful stuff I've come across. In terms of economic models, I've loved experimenting with different ones in the NFT space. For example, a lot of stuff has been first price auctions, but I was able to push forward refundable Dutch auctions in an on-chain trustless way that hadn't really been done before, and I think now has been used by even top artists like Tyler Hobbs. On the other, I think, mathematically beautiful elements that we have, I've been thinking a lot about the lending platforms and the risk that gets taken. You have BendDAO for NFTs. They lend against Bored Apes. And you have, obviously, the Aves of the fungible token world. And there's been a spree of vulnerable parameters on that front. So and currently these lending platforms are all managed by on-chain governance rather than strict mathematical models. They say this gets an 80% LTV, this gets a 20% LTV, and then you adjust those as needs be. But lending as option selling, and therefore should be priced as option selling, is a fascinating element to me. I think that's a critical piece we've only started to explore and is necessary for true on-chain immutability. How do you plug in external liquidity into your risk parameters to avoid a Solin type situation? And I guess another one, I think the VRGDA mechanism that's come out of Paradigm with Art Gobblers is absolutely elegant. The way the multipliers stack additively, the way that it pairs fungible and non-fungible tokens together. I think there's a ton of amazing innovation there that's been obscured by highly volatile price action. So I'm excited to keep digging into that and see what else it might apply to.
For sure. So we'll come back to some of the ZK stuff, I think, toward the end. And we definitely want to get into some of the work you've done on NFT development. But I think one thing it might be interesting to ask now, For those of our listeners who are working on NFT protocols, are building kind of innovative new NFT projects, do you have any advice for them as someone who's experimented with different economic models and done a bit of research and who also has a math background? Do you have any advice for NFT devs on how to like structure a solid economic model or auction process for their project?
So much. I would say it depends at what level. It depends what level you're going at. Key thing is to often try one new parameter or one new model at a time as the world has to learn about things. I think too much newness and user bases can get overwhelmed or not fully appreciate what's been developed. In terms of running a proper NFT project, obviously there are, first and foremost, most important of all, is just basic programming security tips. You want to make sure the smart contract is rock solid, has no security holes that let people steal money from it or that let things get frozen or give undue admin access. So go above and beyond when it comes to testing. Write far more tests than you think are necessary because the hourly rate on saving thousands or even millions of dollars is incredibly high. When it comes to what's the optimal economic model, I think we see a couple of different ones out there. The first, obviously, is free mint plus royalties. And that can be a good way to get your name out there, but it can also encourage excessive volatility on the creator side because creators get paid when things get sold. And so that is not necessarily aligned with just value being driven to the collection. There's also obviously fixed price. The danger of that is that like something costs 0.080 and there are 10,000 of these to sell. The trick with that is you either are oversubscribed, in which case it's often bots that get it all and not like actively engaged human members of the community, or it's undersubscribed and you have this overhang that price can never surpass because people can just mint. So I think it's important to get a good feeling for how much demand there is for something. And one of the best ways to do that is a Dutch auction, which in my opinion maximizes creator surplus, where you start the price starts high and then it goes low and people can buy anytime in between. So you find a market clearing price for whatever the supply is. Key problem of traditional Dutch auctions is that your biggest fans, your best supporters who really believe in it often get screwed because they pay a high price and then it drops more and then other people pay a low price. So how you get around that is a refundable Dutch auction where people pay whatever price they pay. But then the price that it sells out at is everybody gets refunds who paid above that point. So it frees people up to go about their day, stick in a bid, and then come back and claim their refund, and everybody is on equal footing. So that seems like the optimal. And then there's the whole whitelist game of just pick and choose specific people who you think would be good stewards of a project. And that applies to all economic models, really. So those are my thoughts.
Nice. So you have a great piece on royalties, actually, that I'll make sure we link in the show notes. That goes into some of the problems you mentioned with like you're basically rewarding maybe the wrong things in a project that tries to monetize primarily via royalties. But I think some of your auction comments around like Dutch auctions and the work you've done on refundable Dutch auctions are all very interesting. One thing you mentioned there at the beginning, like the prerequisite to picking a new interesting economic model to try out is to focus on security, though. And I think a really good way of saying it, I guess, is to think about the hourly rate of the money you're potentially saving by writing more tests, right? It's unbounded. And the problem is I think people don't normally think about that. They think about it as like, what's the hourly rate of doing this versus doing some other form of software development, and they don't think of it as that different. But you are potentially saving yourself and a lot of people a lot of money and a lot of chaos and embarrassment. So I think that's a really good way of thinking about it. But how do you personally think about smart contract security more broadly? This is something we like to ask almost every guest, and I'd like your thoughts as well.
How do I think about security more broadly?
Just smart contract security specifically.
Mm-hmm. I think, well, first, it's significantly, people don't pay enough attention to it. It's still viewed somewhat as a cost center rather than a profit center. I'm really happy to see better and better tools coming out to support it. For a while, I mean, my tech stack progression within the EVM world went from Truffle to Hardhat to Foundry now. And it's been an order of magnitude quality of life improvement every single time. Truffle, I remember stepping through 20,000 debugger sessions, operations manually to try to see what a variable value was. Hardhat brought console.log to the world. And then Foundry finally lets you get rid of async await madness and write your EVM tests within the EVM. So I'm really happy to see the tool set improving. And you've also got, I think, work on fuzzing that's getting better and better. But it's still a very hard problem. There are a lot of hidden dangers that can come about, and you learn them a lot of times only through hard experience. Hopefully somebody gets hacked, hopefully not you. Hopefully you can learn through vicarious experience. But it's always painful to have those lessons. I think EVM security has stepped it up ever since we had the DAO hack and realized that reentrancy was bad. And now we're moving on. But then we also developed more advanced tools like flash loans that didn't always exist, that prevent novel attack vectors. And now you have to look at, what does full block MEV look like? What does multi-block Oracle attack MEV look like? So I think both the defenses and the attacks are advancing, and it's important to be up to speed.
Yeah, absolutely. I think it's interesting that you bring up things like flash loans as well, right? Because I think a lot of times when we're thinking about hacks and bugs, right, it tends to be, some sort of problem in the software. Maybe you're not handling something correctly, or maybe there's some kind of reentrancy issue or something. But when it comes to things like, especially getting into flash loans and Oracle attacks, right? Like these economic attacks are also like, they're very important, right, to pay attention to. But it seems like they're a lot harder to catch as well, right? Like I don't see that being something that you could necessarily catch in a fuzzing test, right? Like you need to be aware of sort of these like game theory bugs, I guess, right?
Yeah, they aren't necessarily a coding bug. I mean, the code compiles. That's one of my big lessons from the machine learning world, actually, is you have to learn that just because your code compiles doesn't mean it's correct. It just means it's doing something. And you see that with economic behavior a lot of times. So obviously, you can make a syntax error, but you can also make a game theory error of bad risk parameters or reentrancy or something like that. And those are the big ones. Those are the ones that get caught. You almost want your code to throw an error early, because if it throws an error late, 12 months after deployment, that might be millions of dollars lost. So it's a different paradigm of the code compiles, it works, to the code compiles, now let's look at the game theory.
Mm-hmm. Yeah, I think there's probably still room for tooling to be built to simulate some of these game theory and economic things. So hopefully somebody works on that, and I'm sure somebody is thinking about it. So on this topic though of bugs and issues with security that don't come from something directly in the software, one issue here is what happens when approving transactions with a wallet that holds a couple of valuable NFTs, right? And you've actually built a really excellent project called Delegate.cash that helps to solve some more. I mean, there is a technical solution you built, but I think it does solve a problem that goes beyond just a technical. Like it's not only bounded to the technical, right? This is also more of a human and UX problem. So I'd love for you to talk to our listeners about what Delegate.cash is and why it exists.
Yeah. There's this seeming paradox of decentralized self-custody and worldwide adoption, where some people think it's impossible for decentralized crypto, true crypto, on-chain, not your keys, not your coins, crypto to scale to the Robinhood users of the world because it's too complicated and too hard. And to be fair, we have some very painful user experiences right now. Everybody is interacting directly with the base layer, and people sign MetaMask transactions. The transaction they're signing is just a hex blob. How do you know what 0xFoobar means? And so we're getting slightly better human readable transaction simulation methods, but there's always this existential risk of your cryptos on this wallet. If you ever screw up or ever misread a transaction, everything could be wiped from you. And we have, I think, tiers of safety within that. People can have hot browser extension burner wallets that only hold a small amount of crypto. And you can have hardware wallets that are siloed devices that can't have malware on them. And then you can get more advanced multi-sig smart contract wallets that can set certain limits on withdrawals and threshold signers and whatnot. But ultimately, at the end of the day, a lot of these solutions sacrifice significant amounts of convenience for long tail security that's hard to see in the moment. And so my thinking in developing Delegate.cash was, is there a way to do non-custodial, on-chain, true decentralized protection of your assets, but still let you do day-to-day interactions without worrying that you'll lose your life savings? The specific case in point here is Bored Apes getting phished. Every week you log on and somebody else has signed a malicious transaction on a phishing site and lost hundreds of thousands, if not millions of dollars worth of NFTs. So, but you can't stick these assets into a vault and lock them away forever either, because you often have token gating, where Bored Apes are eligible to claim a new airdrop for a mutant serum, for example, but it requires that you claim the airdrop from the wallet holding the Bored Ape. And so users have been trained to make new transactions, make new interactions with the wallet holding their valuable assets. So what Delegate.cash does is it enables you to make an explicit on-chain power of attorney from a cold wallet to a hot wallet, where the cold wallet can be a ledger tucked away in secure physical storage, and the hot wallet is just a burner browser extension or a mobile app or something like that you do day-to-day interactions with. By signing one transaction from your cold wallet, you say, I give permission for this hot wallet to act on my behalf, but not to move any of my NFTs. So then your hot wallet can go in when you're claiming, say, the Bored Ape airdrop, or trying to verify your tokens for a role in a Discord server. And that verifier can just check that you've delegated to the hot wallet and then let the hot wallet claim, instead of having to have you connect your cold wallet itself. So there's a whole host of other use cases and possibilities outside of pure like NFT airdrop delegation. But I think even that has been incredibly necessary, and it's great to see projects start to adopt it.
For sure. No, it's a very important problem, and it has been good to see some of the early adoption with it. So when I like under the hood, right? When I call Delegate and I sign that transaction with my cold wallet, like what specifically is happening under the hood? Like, if you could step us through like what's actually going on, that'd be fantastic.
So what's happening under the hood is there's literally a registry just within the smart contract that stores the cold wallet and the hot wallet and proof that the cold wallet signed it. So you have this big lookup table. You can think of a big Excel sheet or whatnot with the cold wallets on the left side and hot wallets on the right side. And then that gets stored on the blockchain. And then when new projects are trying to integrate this, they can go in and just do a lookup on the registry itself and say, is this hot wallet a delegate for anybody? If so, who? And use that information to approve or deny authorization. So there's a lot of clever stuff we've done surrounding the core mapping to make sure that it's on-chain enumerable, and then there can be multiple delegation, bidirectional, multiple tiers of delegation, et cetera. But at its core, it's just a trusted lookup table.
Nice. And I remember you saying somewhere that there's an interesting network effect that happens as more projects use this. And I definitely see why, right? And I'm guessing that the plan here would be as more projects make use of Delegate.cash, right? It makes it such that it becomes more of a standard that's used throughout the space, which makes it even more likely that if someone wants to go through this delegation process, instead of using some other method, which I'd like you to compare and contrast Delegate.cash to some of the other methods here in a second, but instead of having to, as an app, having to implement all these different methods, ideally everyone just uses something like Delegate.cash and there's a network effect there. Am I correct that that's kind of the strategy with this?
Nailed it. Exactly. So the huge pain point you're trying to alleviate here is that it's 10 times or even 100 times more annoying to go pull out your ledger and verify transactions or signing with it over and over again than it is to, say, use a mobile wallet. So the network effects here are that once a user has delegated once on Delegate.cash for a project, that delegation is permanent. So it can be reused. What that means is you can delegate your wallet once to claim, for example, a Forgotten Runes drop, which happened this Halloween. And then it turns out that Artblocks is doing another airdrop. So you can reuse that initial delegation to claim the Artblocks drop as well. And so the cold wallet can stay even colder. What this means is that you've built up this base of, I think it's 500 or so unique delegators so far. But you have this unique buildup of users who have already delegated. And that is much like liquidity bootstrapping, because now whenever a new project wants to come in, they get these 500 users for free. The 500 users don't have to take any additional security protection to interact on their hot wallet. So if you think of a Venn diagram or a bipartite graph, but a Venn diagram with no intersection, where one circle is the users and the other circle is the projects, and you draw a bunch of lines between these two, each new project that onboards brings their users with them. But then those users can take advantage of the other projects onboarded for free, for no additional cost. So because users are overlapping across projects, there are tons of network effects, tons of reuse that makes it even easier than pulling out your cold wallet every single time.
Yeah, there's a compounding benefit there to the entire ecosystem, which is really interesting. Okay, so you have a pretty good write-up on this. So you don't feel like you have to spend too much time on it. But how does this compare to some of the other attempts to solve this problem? I mean, I think ENS did something that has kind of similar functionality, I think, within if you have an ENS domain. And I think Hot Wallet Proxy is another one that's similar. Can you just give like a quick overview of what you're doing with Delegate.cash compares to those two?
For sure. People have been circling around this problem for a while, and I appreciate all the effort that others have made towards it. But nobody had really gone for a fully dependency-free standalone approach before this. Immutable, unowned approach before this. So DNS, for example, lets you set up subdomains if you own the real domain, which I think is a very useful feature. But it doesn't necessarily scale to smart contracts per se. And there's also a lot of subscription dependency of you need to keep renewing the domain, things can get moved around, etc. So building on top of ENS, I think, is a cool idea, but more interested in a fully standalone setup here that could be deployed on any EVM chain. When it comes to Wanu Labs' hot wallet proxy, I think they took a good initial stab at the problem as well, but several features that make Delegate.cash better. Delegate.cash is fully immutable compared to being an upgradable proxy contract. Delegate.cash also supports tiered levels of delegations, so you can delegate for an entire wallet, for an entire contract, or for a specific token. Much better on-chain enumeration. Delegate.cash supports multiple delegation. So I think all of these are good starts, but ultimately a standard has to encompass a sufficient number of use cases, and DC, I would say, is the only one that does.
Nice. Yeah, I think the immutability with something that's as much of a public good as this is pretty important. But how do you so on the immutability side, some people ask us, like to ask our guests, where they fall on this spectrum of every smart contract should be immutable, and upgradability is really important just in case something happens, or if you want to kind of like take the mindset of just shipping and upgrading as you go. Like, do you have a take, more generally speaking, on whether most smart contracts should be fully immutable or upgradable?
Great question. I've done it all, I would say. I've shipped fully immutable stuff. I've shipped fully upgradable stuff. And I've shipped immutable stuff that got hacked. So I've been through the full spectrum of pain points. My perspective is that the only real public goods that'll win out in the long term will have to be immutable and decentralized. We also have several focuses that, because of their newness and because we haven't fully explored the risks or the needs yet, it's highly likely that immutable approaches will get superseded. So, for example, a lending protocol, to take us back there, needs to be able to update loan to value ratios to account for risks in the market. Whereas Uniswap does not need to be upgraded ever. V2 is not going to break. So I think there are kind of two perspectives in favor of the upgradable side. The first being, what if we made a mistake and need to fix it? And the second being a more philosophical, this is not the best, therefore we will probably have to change it in the future. And I sympathize with both. On the first, it really sucks when you ship bugs. And on the second, this is obviously true. But ultimately, the crypto ethos is about giving people control over their own bearer assets. And that's never really the case if something's just controlled by a multi-sig or an EOA. So I'd say that targeting actual immutable protocols is harder, but more rewarding than the opposite. People have confidence that what you built isn't going to change. And it also requires protocol users to opt in to upgrades. So say that there's a Delegate.cash V2, then that would be an upgrade per se, but one that people could choose whether to start using or to remain on the original. Just the same as people can choose whether they like Uniswap v3 or Uniswap v2 better. So I'd say that I have a lot of sympathy for the upgradability arguments, and I've shipped upgradable stuff myself. So this wording is directed at me as much as anyone else, but it feels weaker. It feels like a stepping stone when you haven't really figured out what you want to do or how you're going to do it.
Yeah, that makes total sense. It's definitely contextual as well.
Yeah, I'm curious. So sort of on this, right? Maybe a sort of balance between the two, and I think this is maybe what some teams intend to or have intended to do, where maybe you have an upgradable protocol in the beginning, so you can rapidly iterate, maybe go for bug fixes, things like this, right? But then provided that it's implemented, you can always sort of revoke that that authority to upgrade in the future, right? And making it effectively immutable. Now, I don't know how often people actually do this, right? Like I'm not aware of like a ton of cases where that power was actually revoked there. But what do you think about a sort of approach like that, where you can kind of go in with this upgradability and sort of this like rapid iteration that you see a lot of crypto startups doing, right? But then having that option there to one day just say, all right, that's enough. It's in a good place. Let's stop here.
Mm-hmm. I think that can be a happy middle ground. The danger, of course, is that good intentions can shift and get abused. But I've actually done that myself. So on one new DeFi launch, for example, we'd done our best to ensure that things were safe and whatnot, but just the sheer scale of funds that were being dealt with, and nobody felt comfortable enough to quite stake their life on it yet. So did a phased whitelisted rollout where initially only EOAs and whitelisted smart contracts could interact. And so this shut off, say, flash loan attack vectors or more complex attack vectors that could be executed in an external smart contract with a one-way toggle to disable this whitelist and make it interactable by anyone forever. And so did several months of a guarded launch phase where only EOAs could interact, and then saw that things hadn't been hacked yet and secured additional audits, opened it up to all. So I do think that approach is definitely, I'd say, messier on the ops and coding and trust side, but it is a viable middle ground.
Makes sense. I think that's good advice, and I appreciate you sharing some of your personal experience with it. On the side of actually like building contracts, right? So Delegate.cash is an example of a set of contracts that's probably going to be used by lots and lots of devs in the space. So you had to really think through the naming. You had to think through like effectively the API design of what this was going to be, what it was going to look like, and what the experience was going to be like for developers building on top of it, right? And I think there are a lot of people that listen to this that are either working at protocols or working on protocols. They want to be used by other people. So I would love your thoughts as someone who's done a lot of engineering work in their career on API development in general. Are there any, is there any advice at all you have about building contracts or APIs that are really, really good experiences for other developers to build on?
Mm-hmm. Simplify. I think the midwit trap of code development is to stack as many specialized features and as much difficult code and as many fancy interfaces into a project as you can, just to show that you're capable, because it is impressive that you know how to do these things compared to a novice coder. But then the real advanced trick is, how do you make something not so complicated that you can't find a bug in it, but so simple that so simple that it's understandable by everyone. and I wouldn't say I'm perfect at this yet, but trying. If you're trying to build a key building block of the space, other people's attention is the scarcest resource. And so things have to be both dead simple to understand and dead simple to implement without ways to screw it up. So one argument that I've heard, for example, is if you have a simple API and then somebody comes in and says, hey, there's this weird edge case that 1% of users might use. We should stick it in there. And initially it seemed like there's no harm because A, you haven't broken any existing functionality. And B, if this turns out to not be what people need, then they can just choose to not use it. So what's the harm in adding this complex edge case? But it turns out the harm is in the attention. People come to your website or come to your documentation, and instead of there being one clear way to do things, now there are 7 ways. And they have to go consult outside resources to figure out what the trade-offs are of each, blah, blah, blah. So it's actually, I think, a sign of excellence. And I would point out Stargate, for example, the layer 0 bridge as a shining example of this, that heavy simplification towards what people really need is the sign of great code and great APIs.
Yeah, it's like the bell curve meme. You should make a bell curve meme for Twitter. Just make it easy on both sides and then some kind of complicated thing in the middle. Yeah, that's a great way of thinking about it. And I think you're right.
That'd be beautiful. Yeah.
Yeah. Yeah. No, that'd be cool. But I think that's excellent advice. On the side of again, this community standard stuff. So we at Superfluid, we have some people on our team that have drafted up an EIP, right? To try to take something we've built and make it standard in across the space. You have an EIP out, I think, with regards to either Delegate.cash or something related to it. I would love to just maybe get the background of what the EIP is, and I'd also like to understand what your experience has been like drafting and garnering support for that EIP. Do you have any high level advice for people that are looking to do the same?
Yeah, EIP is a high level grouping that I think is better separated into 2 subcategories. The first being we're making an actual change to the EVM. We want to add this opcode, and that is very, very, very hard to do. And the second being, hey, we have an idea for a community standard. We're going to publish it on the Ethereum Magician's website. So I've done both. I was pushing decently hard. I can't even remember what it was now. I think I was pushing for an opcode that let you say which transaction in the block you were. So like block.tx number would be 1 if you were the first transaction. It could be 130 if you were just somewhere in the middle, and so on, for I think user protection and seeing if they were getting sandwiched or not. That one just never, I think, didn't get the traction it needed. With Delegate.cash made the second community standard, and that was more of pushing out the interface and saying, hey, people should adopt this common interface. I think it's a bit of an interesting case. First, I think Wilkins Chung from Manifold was the one who actually drafted and put it out there. So can't say this was all me. But Delegate.cash is an interesting one because it's best used as a singleton registry instance where there's just one of it and everybody uses the same one. Then like a Uniswap V2 style interface where there are lots of forks of the same DEX, but they all use at different places and they all use the same interface. So in terms of, I would say just that the EIP process is brutal and unforgiving, and you have to drum up a lot of support, almost like a grassroots political campaign if you want stuff to go anywhere. And that happens on traditional media platforms rather than Ethereum magicians.
Yeah, definitely. I've kind of been somewhat passively involved with the transient storage opcodes, and it's pretty political. It's actually very surprising to see like how like how in depth these conversations go, right? And it's honestly, it's a little intimidating, right? Because you have these people that have decades of experience that know so much about these machines, and they're hard conversations,
And you get they're still trying to deprecate self-destruct in the year 2022. And you come in, you have people like, no, I run an MEV bot that depends on this. I'll lose my livelihood. Like, but this is literally one annoying thing. We stuck it in there on accident. Nobody's supposed to actually be using it. But you have these two guys that, will spend their life campaigning against even obvious good changes. So what's the opposition like on transient storage?
So I guess the quick rundown is against says that it adds too much complexity to things like formal verifiers and fuzzers. And then it also adds complexity to the languages. So Huff and Viper already support transient storage through some like low-level interactions, just a built-in function, tstore, tload. Solidity, on the other hand, so there's a fork that allows you to do it with YUL, like inline assembly, which works. But if you want to get sort of like dynamically sized data, then you're basically going to need, you're either going to need to write a lot of assembly, or you're going to have to use the transient keyword, like struct transient variable name, right? Like is how you would declare that. So there's just a lot of complexity that comes with that. And then I think there was something else. I want to say that there were some complaints that maybe the actual specification wasn't fully fleshed out and needed a little bit more work, but it is a candidate for Shanghai now. So pretty hopeful for it overall.
Nice. Yeah, we'll have to see. The less assembly scratchpad voodoo magic, the better.
Yeah, absolutely.
For sure. Yeah, so be careful out there, kids. Before you get involved in an EIP battle, you better do your research, because someone will come in hot and roast you. Okay, so getting into even more general things now, right? I think some of your advice on API design was really good, and same thing with smart contract security. One thing we like to ask people that come on that have written a lot of smart contracts, have built a lot of projects of their own, is whether or not you have any particular design patterns or optimizations that you built in somewhere that you feel very proud of, that you like to call out. Could be anywhere. It could be in Delegate.cash stuff. It could be somewhere else. Anything you like to call out, feel free to do so.
That's a good question. I think nothing particularly comes to mind. I mean, I'm reasonably proficient in all the gas optimization tricks everybody knows and loves, whether that's struct packing or bit masking or whatnot. I think I wrote a whole article explainer on the different types of upgradable contracts, and when you should use each of them. Ironic, because I'm now arguing for full immutability wherever possible, but good to know the enemy. Maybe those pieces have worked.
Cool. Yeah, I'll link to that article on upgrades in our show notes, along with the royalties piece that I mentioned earlier. What about things that you think are often misunderstood, or maybe any common mistakes you see amongst maybe like more junior Solidity devs and people in the space?
Common mistakes. So there's, if we're listing off just random tidbits, I think one fun thing to know is that when you make a variable public, its read function also gets exposed. So there's no need to write a separate getter like you would in Java or something like that. Yeah, good to, you can pack timestamps into smaller, I think it's 32 bits instead of 256. And then you can pack that into larger 256 word, or into 256-bit words for structs. But in general, I think that the tool chain you use is more important than you'd think. I know there are some people I'll spar with on Twitter who still do a significant amount of their development in Remix, which is an online IDE instead of a local environment. There are people who will use testnets to run their test suite. Like instead of writing automated tests, they will deploy a smart contract to Goerli, and then they will go in and click buttons on Etherscan and then see if it did what they wanted it to do. And that's fine as a last step before you entrust it with millions of dollars. But for the development process, I think an automated test suite and using the right tool chain, like get into Foundry, stop using more archaic frameworks can be useful.
Are you mostly Foundry now then? I think so. I didn't look too deeply, but I think that the Bored and Dangerous repo you have on your GitHub is definitely a Foundry repo. Did you do Delegate.cash in Foundry, or was that a hard hat project?
Yeah, those have both been in the past couple of months. So those are both Foundry. I have hard hat and truffle stuff out there, I think, but all my active development is now focused on using that tool chain.
Nice. And while we're on it, actually, what was the Bored and Dangerous repo? What's going on in there? I saw some interesting things in the README, but I wanted to let you explain it.
Yeah. So backstory there. If you cycle back 15 months now, there's a project called Jenkins the Valet, which the whole backstory was there's a bored ape who is a valet at the yacht club and gets told all the secret information and writes a book about his experiences. So co-founders of this actually went out and made a whole physical book and listed a New York Times bestseller, Neil Strauss, and wrote a whole illustrated book about the bored apes. And then as a companion drop to that, they came out with virtual NFT copies of the book that would then give you token gating to be able to read the real thing. And so basically oversubscribed demand, couldn't figure out the optimal pricing model. I came in, recommended that they run a refundable Dutch auction, despite a lot of people having denigrated that because all Dutch auctions up to that point had failed. The most famous visible one being Aku Dreams, which was, I think, a Major League Baseball player made something about astronauts. But they raised 32 million, and then their withdrawal function had an off by one error. So it got locked. So all 32 million got locked in the contract forever. And it's still there, just locked because no one can get it out. I think now with the ETH price drop, it's hovering around 10 million. So I don't know if that makes you feel better or worse.
Oh, that's consolation.
There was a lot of fear around Dutch auctions and how they were broken. But my opinion was that the mechanism was not broken. You just got to not hire devs off Fiverr. So came in, wrote a refundable trustless Dutch auction that both calculated the refunds, but also spit them out autonomously instead of needing, like, any user could claim their own. But it could also be batched by an admin but couldn't be stolen by even a malicious admin. So, and it then launched and it went perfectly. I think was able to refund thousands of people trustlessly in under 3 minutes after it sold out. So proud of that.
That's amazing. Yeah, I was going to ask you if you had any resources on refundable Dutch auctions when we hopped off the episode, but I guess the resource is to go look at that repo, which is pretty dope.
Yeah, I did. I went ahead and tried to split things out, the idiosyncratic code of that drop and just a general refundable Dutch auctions template. So it should be there in the repo.
I love it. Okay, so last couple questions for me as we wrap up here. The first one before we ask, like, one of our last questions is I think your Twitter bio. Last time I checked, it says you're working on something new. You might even be hiring for it. Do you want to tease that here, or do you want to keep it private? It's up to you, but this is maybe a good opportunity to talk about it if you want to.
Yeah, I think keep that private at the moment. Got some exciting initiatives, I would say. So, yeah, launch when it launches.
Cool. No, respect that. I'm sure it'll be cool, whatever it is. But the last big question is, We ask this to everyone as we wrap these up, but let's say we look ahead at the industry right now. We haven't talked about any of the mania that's going on as we record this in November 2022. That's by design. But if we look at like the future of what crypto looks like, in the early 2030s and throughout the rest of the 2020s, what do you hope we achieve? Like, what do you hope things look like in 10 years after we all keep building and put our heads down and really just get things done? Do you have like a high level vision for what you hope things look like, or no?
Great question. I'd say crypto is all about permissionlessness and unlocking the other 90% of the world who doesn't necessarily have the connections that an accredited American with a college degree might have. There are so many smart people out there, and just by virtue of where people are born, or their economic situation, or prejudices, or various other surrounding factors, I think people don't get the opportunities they deserve. So that's one of the big appeals of crypto to me, is it opens up a level playing field where anyone, no matter who or where or what or how they are, can come in and publish stuff and use stuff. And so it turns what has been this cloistered Americentric that taps into maybe tens of millions of people's talent, or whoever can game the system properly, into a much more open system that both lets people compete to build better products, but also lets everyone benefit from better products. The downsides of uncomfortable competition are more than outweighed by the better world that comes when you get everybody's talents into the mix. So I'd hope that we get everything we need to make that a reality. There are lots of sub niches. I think privacy is critical. I think better tools for true self-custody are necessary. I think that I'd love to see things scale beyond just pure finance. That's more of a bandwidth constraint than anything else right now, is that we only have so much block space, and so only so much can get put on chain. But in general, I just hope it leads to a more open, permissionless world.
Great answer. There you go. For those of you listening, that are looking for something to build, Foobar just gave a couple of things right there. But listen, we really appreciate you coming on. This has been a really awesome conversation.
Thanks so much. It's been great talking.
Absolutely. And where can people find you online? Is it just at 0xFoobar? Is that right?
Yep. Twitter is probably the best place to reach me, at 0xFoobar.
Awesome. Well, thank you again. We appreciate it.
Have a great one.